Now we discuss information diagrams for Markov chains. If random variables x1, x2 up to xn form a Markov chain, then the structure of mu star is much simpler, and hence the information diagram can be simplified. For n equals 3, for example, x1, x2, x3 forms a Markov chain if and only if I x1, x3 given x2 is equal to 0, or mu star x1 tilde intersect x3 tilde minus x2 tilde is equal to 0. Therefore, the atom x1 tilde intersect x3 tilde minus x2 tilde can be suppressed in the information diagram. Suppose I x1 x3 given x2 is equal to 0. Then mu star x1 tilde intersect x3 tilde minus x2 tilde is equal to 0. This is indicated in the information diagram. Now suppress the atom of x1 tilde intersect x3 tilde minus x2 tilde by setting it to the empty set. This can be achieved by displaying only the upper part of the information diagram. By redrawing the upper part of the information diagram, we obtain the information diagram at the bottom, which consists of 3 consecutive mountains representing x1, x2, and x3. We now further discuss the structure of mu star for a Markov chain x1, x2, x3. In this information diagram, I x1, x3 given x2, which is equal to mu star x1 tilde intersect x3 tilde, this is given by the red dot in the diagram, minus x2 tilde, which is given by the 4 blue dots. So what we get is the empty set, and mu star on the empty set is equal to 0. And therefore, I x1, x3 given x2 is equal to 0. Also, consider the atom x1 tilde intersect x2 tilde intersect x3 tilde, which is the atom shown here, is seen to be the intersection of x1 and x3. Therefore, the value of mu star on x1 tilde intersect x3 tilde is equal to I x1 x3, which is non-negative. Thus, we have shown that mu star x1 tilde intersect x2 tilde intersect x3 tilde is non-negative. Since the values of mu star on all the remaining atoms correspond to Shannon's information measures and hence are non-negative, we conclude that mu star is a measure. We have shown that for 3 random variables forming a Markov chain, the structure of mu star can be simplified, and hence the information diagram can also be simplified. This theme can be extended to 4 random variables forming a Markov chain. For the Markov chain x1, x2, x3, and x4, it turns out that mu star vanishes on the following 5 atoms. Because of this, the information diagram can be displayed in 2 dimensions. The values of mu star on the remaining atoms correspond to Shannon's information measures and hence are non-negative. Thus, mu star is a measure. This is the information diagram for 4 random variables x1, x2, x3, and x4 forming a Markov chain. We now further discuss the structure of mu star for the Markov chain x1, x2, x3, and x4. We start with the generic information diagram for 4 random variables x1, x2, x3, and x4, shown on the lower right corner. First, we consider the Markov subchain x1, x2, x3, which implies that the mutual information between x1 and x3 given x2 is equal to 0. Now, this mutual information can be written as a sum of two terms, the first being I x1, x3, x4 given x2, and I x3 given x2 and x4. You should try to verify this identity on an information diagram. Notice that in this identity, x1 and x3 are unconditioned in all the terms, and x2 is conditioned in all the terms. x4 is unconditioned in the first term on the right-hand side, which in set theoretic representation correspond to taking the intersection with x4 tilde. And x4 is conditioned on the second term on the right-hand side, which in set theoretic representation correspond to minus x4 tilde. Now let the second term on the right-hand side, which is a conditional mutual information, be equal to A, which is non-negative. Then, the value of the first term on the right-hand side must be equal to minus A because they add up to 0. This is shown in the information diagram. Next, we consider the Markov subchain x1, x2, x4, which implies the mutual information between x1 and x4 given x2 is equal to 0. Again, we write this mutual information into two terms on the right-hand side. The first term on the right-hand side, namely I x1, x3, x4 given x2, is seen to be minus A, and so the second term must be equal to A because the two terms add up to 0. This is shown in the information diagram. Now we consider the Markov subchain x1, x3, x4, which implies I x1, x4 given x3 is equal to 0. Again, we write this as the sum of two information measures. The second information measure is seen to be equal to A, and so the first information measure must be equal to minus A. This is indicated in the information diagram. We now consider the Markov subchain x2, x3, and x4, which implies I x2, x4 given x3 is equal to 0, and again, this is written as the sum of two information measures, where the first information measure is seen to be minus A, and so the second one must be A. This is indicated in the information diagram. Finally, we consider the Markov subchain x1, x2 together, x3, and x4, which implies I x1, x2, semicolon x4 given x3 is equal to 0. Now this conditional mutual information can be written as the sum of three information measures. The first one is equal to A, the second one is equal to minus A, and the third one is equal to A. This is indicated in blue in the information diagram. And therefore, we have 0 equals A minus A plus A, which is equal to A. Therefore, A is equal to 0, and so mu star vanishes on the corresponding 5 atoms as shown in the information diagram. We now discuss the non-negativity of mu star for the Markov chain x1, x2, x3, x4. We have proved that mu star vanishes on the 5 atoms shown in the information diagram. Suppress these atoms by setting them to the empty set to obtain the information diagram below. From this information diagram, it can readily be checked that the values of mu star on the remaining 2 to the power 4 minus 1 minus 5 equals 10 non-empty atoms are equal to these information measures. These are all Shannon's information measures, which are always non-negative. Therefore, we have shown that mu star is a measure. As an exercise, identify these 10 atoms in the information diagram at the bottom. For a general N, the information diagram can be displayed in 2 dimensions because certain atoms can be suppressed. The values of mu star on the remaining atoms correspond to Shannon's information measures and hence are non-negative. Therefore, mu star continues to be a measure. See Chapter 12 for a detailed discussion in the more general context of Markov random field.